Okay, welcome back to measure of dispersion. So now we will continue with the next learning outcome here, which is box plot. So today we will cover how to draw the box plot. The box plot is not included in your progressive check 1, but it will be tested in the next progressive check. So box plot, there are a few names for it. They call it a whisker plot, a box plot, box and whisker plot. They all mean the same thing. All right. So what is a box plot? Something you've never done before. So what would the box plot show you? Box plot looks like this. There is a box and there are whiskers. Okay, this is how a box plot looks like. Okay, what does a box plot show you? Your minimum data. That means the smallest data, the smallest value in the data set, Q1, Q2, Q3, and the maximum value. So therefore, you must be very well versed with calculating your Q1, your Q2, your Q3. That is why I always say chapter 2 and chapter 3 are very interconnected. You cannot do chapter 2, you won't be able to do chapter 3. All right. So what is the purpose of drawing this box plot here? Okay, you will be able to see the presence of outliers. So what is an outlier? An outlier is actually an extreme value, a value that is either too big or too small to be present in the data. Okay, how do you identify whether this data is an outlier? I'll teach you in a bit. But outlier means a value that is either too small that needs to get out, or a value that is too big that needs to get out. All right. What is the next purpose of a box plot? Is to see the shape of the distribution. Okay, what does it mean by shape? I will show you now. Like this is quite symmetrical. So if you look at certain box plots, look at this, you can see the shape of the distribution. When one is short, one is long. This we will learn actually in chapter 4. How do we comment on the shape or the spread of the data? Okay, so your box plot is divided into 4 sections, 25%, 25%, 25%, 25%. So this is your minimum value, meaning the smallest value in your data. You will draw a line, come out like this, and then you will draw a box. The box will represent your Q1, Q2, and Q3 value. So you basically need 5 values. Minimum, you draw the must have scale. All these will have scale. So your minimum, you draw it out, you draw a box. This will be your Q1 value, Q2 value, Q3. You come out, this is your maximum value. All you must label, all right? So what does your box plot show you? There might be outlier or not. Like the box plot I showed you earlier. See, this is so short, this is so long. So maybe this is an outlier, maybe. Okay, so you are able to basically see, give me a minute. Basically see whether there is outlier or not, and a value that is extremely large or small. You can find the range. That's definitely it, right? What's range? Take the biggest value minus the smallest value. All right. Then you can find IQR, which is Q3 minus Q1. You can see your median, which is the middle of the data, shape of the data, and these two we will learn in chapter 4. So for this part, you must know, this chapter, you must know how to draw box plot. And you must know how to identify outliers. These are the learning outcomes for this lesson. You must know how to draw the box plot, and you must know how to find outlier. All right. Let me just go to the manual and show you where am I in the manual now. I'm actually on page 91 and 92. This is what I'm going to cover today. All right. So drawing the box plot, I've quite a bit shown you. So the 5-number summary, let's say they give you, what's a 5-number summary? Minimum, maximum, Q1, Q2, Q3. So when they give you something like that, you must first of all come up with a scale. Must have scale. You cannot just simply say, oh, I'm going to draw the box plot. You just draw how you want. Cannot. Must have scale. So like in this case, the scale is 0, 50, 100, 150, right? So 23 is your small value. So you put 23, you come out. Q1, 37. So 37. Q2, 77.5. Q3, 105. Then you draw the box. So your box is basically Q1, Q2, Q3. Then you branch out, that's your maximum value, 122. Must have scale, all right? So now the next part is outlier. What was outlier? I told you, an extreme data which is very far away from all the other data, which you don't want to include. That is an outlier. But how do you find out? How do you know whether the value is an outlier or not? There is only one way to find out. There's no guessing game here. There's only one way, which is using these 2 formulas here, which is the lower boundary formula and the upper boundary formula. This formula is not given to you in your formula sheet in your exam. You got to memorize it. So basically your lower boundary and upper boundary is more like a fence, or more like a limit. That means you can only accept between these two values. Whatever outside of this is an outlier. So your lower boundary, how do you calculate? Q1 minus 1.5 times IQR. Now a common mistake within students, right? They'll plug the whole thing in a calculator one shot. Cannot. Here is multiplication, so you got to do this first. So if you want to plug the whole thing into the calculator one shot, this part you got to put a bracket. Don't forget, students always forget and get it all wrong. Q3 plus 1.5 times IQR, so you got to put a bracket here. So you must understand one thing. You calculate your Q3, Q1 wrong, everything is going to be wrong. Okay, so you got to find your lower boundary and upper boundary. Now when you want to draw your box plot, let's look at the steps that you need to find. You need to calculate for me. You need to find 5-number summary first, minimum, Q1, Q2, Q3, maximum, because that's what you need, right, for your box plot. You need to find your upper and lower boundary if asked. What do they mean by if asked? If they ask you to show outlier or remove outlier. So you can add this in your manual. Those of you who have printed your manual, please add it. All right. When they ask you to show or remove, you need to calculate your upper and lower boundary. And then you need to identify the outlier. Identify meaning you calculate your upper and lower boundary and you're going to see, is there anything outside of these boundaries? Are there any outliers? Oh yes, this is it. So you will show. I will teach you later how to show. Then you will draw and you will label. I'll teach you how to label as well. So there are 3 types of box plot that you must know how to draw. Usually it will be tested all the time. The first one is just the basic box plot without any outliers, the one that I went through with you here. Just a normal box plot. Find your 5-number summary, just come up with the scale, just draw. Easiest of them all. Show outlier and remove outlier is what is a little bit different. Students always get the second and third one wrong. Okay, your box plot must have a title. Everything you draw from now on must have a title. Okay, let's look at the example. They've given you the 5-number summary here, right? So come up with a scale. You can come up with, you don't need to start with 0, no problem. You want to start with 4, 5, no problem. So 5, 6, do you see the scale here? Okay, then you draw minimum 5. Come out, branch out. Now you're going to draw the box. The box starts with Q1, which is 8, ends with Q3, which is 13. And in the middle, you have Q2, which is 11. So draw. Must draw the box out. Then you branch out to your maximum value. It must look exactly like that. Please don't go and draw anything of your own in your own universe. I don't want to see all that. It must look the way you see it here. Because a lot of students will draw all kind of things for me. I don't want to see all that. It must, this is how your box plot look like. You must draw it this way. Then you label minimum 5, Q1 8, Q2 11, Q3 13, maximum 14. Title it. Alright, so let's look at your first example here. They have given you the data. What you need to find is your 5-number summary, right? So what's your 5-number summary? Minimum, Q1, Q2, Q3, maximum. Alright, I'll go back to the slides now. Okay, I believe this is it. 5, 7, 13, 13, 13. Okay, so this is it. So now if you look at this question, they just ask you to draw the box plot. They never tell you show outlier, remove. So you no need to find upper boundary, no need to find lower boundary. This is just here because this is a teaching slide. It's just to show you only. Alright, so what's your minimum? 5. What's your Q1? 8. What's your Q2? 12. What's your Q3? 13.5. What is your maximum? 18. Come up with a scale, no problem. You can start from 5. Branch out Q1, Q2, Q3. Draw the box. Branch out maximum. Label minimum 5, Q1, 8, Q2, 12. Must label the way you see it here. Don't just write 5, 8. Oh, can what? No, cannot. You have to follow the labeling. Okay, what I meant by upper and lower boundary is this. So here we have done some extra things just to show you. Lower boundary is negative 0.25. Upper boundary is 21.75, meaning use the formulas that I have taught you. Okay, Q1 minus 1.5 times IQR, Q3 plus 1.5 times IQR, that is your upper boundary and your lower boundary. When you find them, you see everything is inside the boundary, right? Therefore, no problem. No outlier. Understand? Okay, so that's example 1. So please pause the video as you go along. You can pause, draw this, make sure it looks correct, then move on to example 2. Example 2 states, draw a box plot and show outliers if any. The moment you see show outliers, so you got one extra step. You find 5-number summary and you got to find upper and lower boundary too. So let's look at the example here. So you find your 5-number summary first. Minimum is 5, maximum 21, Q1 is 6, Q2 is 10, Q3 is 13. So you find your 5-number summary. Then you got to find your upper and lower boundary. Alright, you find your upper and lower boundary and see whether there are outliers or not. Okay, so your lower boundary that you will get here will be negative 6 point something or 4 point something, which is very much smaller. Although it's not here, but when you draw, you must try to fit it into your scale. So that is why I always tell students, don't go and draw the box plot straight away. When they ask you to show outliers, don't go and draw straight away. You find your 5-number summary, you find your upper and lower boundary, create a scale that can fit everything inside. What you want to do, double job, create a scale that you can fit everything in, then you dotted line lower boundary. This side, that means your dotted line will be here. Dotted line lower boundary, dotted line upper boundary, and you draw. So what is happening here? Is there an outlier? No, because it's within the, it's inside the boundary. Okay? It looks like there is an outlier. Why? Because one short, one so long. Looks very imbalanced, right? It shouldn't look imbalanced like that. It should normally be quite balanced. But it doesn't mean if it's imbalanced, yes, it's not an outlier. There's only one way. Find your upper boundary, lower boundary, draw it out, dotted lines. All right? So that's about example 2. Example 3, again, they told you show outliers if any. So when they tell you something like that, find your 5-number summary. Okay? Find your 5-number summary. And so this is the data. This is the slide for it. Find your 5-number summary. Let me just bring this a little lower. Okay? Find your upper and lower boundary because it's not in the region. Just give me a minute. Okay? Find your upper and lower boundary. All right? Now, they ask you to show outlier, right? So show outlier is like this. So you find your 5-number summary already. Then you find your upper and lower boundary. So your lower boundary is negative 0.25. Your upper boundary is 21.75. So you must have a scale, right, that starts from negative all the way to make sure be able to fit 21 point. No need to be so accurate. You can just use like the scale that you see here, 0, 1, 2, 3, 4, 5. No problem. Although you just you just estimate negative 0.25, oh here, then just draw the dotted line. That is your lower boundary. Meaning that is your limit. Anything that is outside will be an outlier. So right now, you're quite good. Your minimum is 5, right? So, okay. What is your upper boundary? 21.75. So go to 21.75. Estimate. Just estimate. Nobody's going to check. You can't even draw it accurately one. So you dotted line. That is your upper boundary. Label it. Now let's draw. What is your 5-number summary? Minimum 5. Come out. Q1 is 8. Alright. Q2 is 10. Q3 is 13.5. You draw the box. Now there is a problem here. What is your maximum? 22, right? Is 22 outside the upper boundary? Yes, your upper boundary is 21.75. Meaning anything outside of this boundary is an outlier. So what does that tell you? This question, the 22 is an outlier. That is how you identify outlier. You cannot just say, it looks very far, so it's an out. No. You must find upper boundary, lower boundary. Anything outside of them are outliers. So right now you have confirmed 22 is an outlier. How you confirmed it? Because my upper boundary is 21.75. Anything outside is an outlier, correct? So when they ask you to show, they never ask you to remove, they ask you to show. That means it's still in the diagram. You show it as a dot. Do you see this dot here? You show it. This one students always get this wrong. I don't want you to get this wrong. You show it as a dot. Do you see the dot there? So you show it as a dot. So now 22 outlier, right? You will move to the new maximum value, which is 16. That means you move to the next value. 16 is your new maximum. Do you understand? So when they ask you to show outlier, find your 5-number summary, find your lower boundary, find your upper boundary. Make sure the scale can fit these two. Draw dotted lines, start drawing your diagram, Anything outside, you show as a dot and just move to the next value. Okay, for an example, if you have let's say 5 is an outlier, example. So you draw the 5 as a dot, your new minimum will be 7. Okay? All right? Okay, move on to the next one. The last example here, they asked you to identify and remove. Students hate this question. Why? Double job. Why double job? First, you need to find your 5-number summary. I'll just write the steps down for you. Okay, first you need to find a 5-number summary, original values. Okay, then you need to find upper boundary, and you may want to write this down in your manual, and lower boundary. After you find your upper boundary and lower boundary, you need to identify your outliers. Okay, you identify your outliers. Then you remove it. So when you remove it, what happens? What happens when you remove? Your n number of data will change, will reduce, right? Because you are removing something. Then you have to recalculate your 5-number sum. So these are the steps when they ask you to identify and remove. Write these down, please. These are the steps that you must follow. Okay, you find the 5-number summary for the original data, original. Okay, then you find your upper and lower boundary, identify the outliers, take it out. Then because the number of data will reduce, you need to recalculate your 5-number summary. So I'll show you the slide. We are moving on to the slide now. Okay, so this is the data that you see here, 5, 7, 9, 10, 10, 16, 22. Basically, in this question, this data and this data is the same. So you no need to do double job lah. You already know 22 is an outlier, right? You already know that. So you're going to remove 22. Now you're going to calculate the new 5-number summary. That's it. Just remember one thing. No need to find upper and lower boundary. When you remove outlier, right, you notice I didn't ask you to do it here also. When they ask you to remove, you no need to find upper and lower boundary already. Why? You already remove outlier. What's the purpose of finding it? Wasting time. Understand? So you recalculate your 5-number summary, just draw. Understand or not? In this situation, the data from earlier and now is the same. That's why you already know 22 is an outlier. If they give you a different set of data altogether, you need to do all these steps one by one. So I'll suggest for you, please write these down in your manual. Follow this religiously. You will never go wrong. Okay? So basically, that's how you draw your box plot. All right? So there is an example here in your manual. Do you see this example here? Example 5. Okay, so basically the solution is here. Please try to go through it. So you rearrange from small to big first, then you find 5-number summary. Students always they will remember now. After when during exam, when they ask for 5-number summary, they have no idea what I'm talking about. So 5-number summary is minimum, maximum, Q1, Q2, Q3, all right? So you rearrange, find your minimum, maximum, find your upper and lower boundary. Then you are going to actually draw your box plot, identify outlier, show outlier. See, the first one they told you, just draw. Second one, show outlier, they show as a dot. Okay? All right, so now I want you to start doing exercise 3.2. All right? Exercise 3.2, let's move on. So you have exercise 3.2. Basically, this was a dot plot. You basically, you have to extract out your data lah. So you have 1, 2, 3, 4, 5, because 1 repeats once, 2 repeats once. You remember all this, right? That's why I say semester 2 is very interconnected. If you haven't been doing your work, you will be very lost. 1, 2, so your data is what? When you open it up, 1, 2, 3, 4, 5, 6 will repeat 4 times. Do you see that? 7 will repeat twice. 8 will repeat 4 times. 9, yeah. So you ungroup it. And then you find your 5-number summary. In this situation, they've only asked you to draw the box plot. They never asked you to show outlier. But this is a teaching slide. I have drawn the lower boundary just to show you the lower boundary is 1. The minimum value is also 1. Is it an outlier? No. It is only an outlier if it falls outside the boundaries. Meaning if it falls this side. Outside. Okay? So I want you to complete question 2 as well. I want you to complete exactly 3.2 everything. So this is ungrouped data. You rearrange and you sort it out. all this, all right? So here, they've already given you the box plot, okay? Remember one thing, the box plot is what? From minimum to Q1 is how many percent? 25%. Q1 to Q2 is 25%. This is the trick to answering this question. If not, you will have no idea what I'm talking about. Q2 to Q3, 25%. Q3 to maximum, 25%. So list the 5-number summary. That's not a problem. Your 5-number summary, your minimum will be, give me a minute. So your minimum will be 20, 24, 33, 34.5 and 40. That's your 5-number summary. Less than 24. Less than 24 is this part, right? How many percent is this part? 25%. So 25% out of 40 will give you 5 students. That's how you find the answer. Either less than 24 or more than 34. That means either this part or this part. So 25% plus 25% is 50%, which is half of the students. 50% of 40. What score did approximately 50% of the students exceed? 50% is your Q2. What's your median? What's your median here? 33, right? So the 50% exceeded a score of 33. Okay, so same thing here. You have the dot plot, find the median, generate the box plot. Same thing here, find your 5-number summary. Minimum is 0, maximum is 8. This is your frequency here. So you basically have to come up with your frequency distribution table here in order for you to find your Q1, Q2, Q3, because you need cumulative frequency. So you basically write 0, frequency 15, 1, frequency 11, 2, frequency 15, 3, frequency 11. So you got to come up with the table. You have no choice, okay? I'll show you here that you come up with this table, use cumulative frequency and find it. Okay, same goes to question 6. Something in question 6 that you can actually read out. Yeah, that is question 6 for you there. Construct the box plot. You don't worry. I know here you cannot see accurately, like 25% you cannot see. Don't worry, just estimate or not, just take the values from here. I have no problems, because in your exams you will be given an accurate graph. It won't be like this. This is very vague, so you no need to worry. Okay, question 7, I want you to try first. Question 7 is a little bit different. Discrete data, the trick lies here. What is discrete data? Data that is whole number, cannot be decimal. All right, so what is the smallest change that can be made to the maximum value so it will become an outlier? How can you make it an outlier when it's bigger than the upper boundary? Why am I saying upper boundary? Why upper boundary? Because we are talking about maximum value. Understand? That's why I'm talking about upper boundary. So what changed? How do you make it an outlier? So you first of all find your upper boundary. You will see your upper boundary is 5.75. Okay, so right now, how do you change this? 5.755 is not an outlier, right? You want to change it and make it an outlier. So you increase it by 1, meaning it becomes 6. Why by 1? Because this is discrete. The data must all be whole number. A lot of students, why means 5.76 can what? No. 5.75 is your upper boundary. You must increase it by 1. You cannot increase by decimal place because this is discrete data. That is the smallest change that you can make. All right, so today I would like you to basically complete exercise 3.2, question 1 all the way to question 7. Any questions, please do ask me. All right, so basically that's about it for chapter 3. We have completed chapter 3 now. You must know how to find your MOD, which is range, interquartile range, standard deviation, variance, using group data, ungrouped data, group data with intervals or without. And you must know how to draw the 3 types of box plot that we just covered today, which is just draw, show outlier and remove outlier. You must be very well versed. Chapter 2 and 3 takes close to 40 marks in your final exams. So it is quite a heavy chunk in your exams. So you must make sure you get it right. All right. Any questions? Please ask me. Okay, so we will stop here for today. Thank you.